We're continuing our discussion on solving systems of equations that involve linear functions. And instead of using the methods we discussed previously, which were substitution and elimination, we're going to use a third method, which is known as the matrix method. Matrices is a great tool to solve systems of linear equations. Once again, this only works for linear equations. And the method is known as the row reduced echelon form. What? This thing right here. The row echelon form, the row or the reduced row echelon form to be even more specific, is what we are going to attempt. And we're using row operations to make this happen. When we obtain a matrix that is in this row echelon form, what it's going to look like, we'll have ones on the main diagonal and zeros underneath it. So let me show you a really brief sketch of what that's going to look like. You've got rows go across, okay? So rows go across. And so let's say you've got one, 2, 3, 4, ... Let's go to 10. This is worst case scenario. And then underneath it, you've got 0, 1, 2, 3, ... whatever you want to stop at. And this keeps going in this same pattern. And so when we talk about the main diagonal is made up of top left corner number, and then you go down at a diagonal. And that is the main diagonal. All right, matrices are probably a brand new concept for all of us. So this is just we're just going to touch on matrices just a little bit in this class. So the first thing we need to understand is the main diagonal of a matrix starts at the top left corner, goes down and towards the right in a diagonal fashion, and that's what we call the main diagonal. All right, the next thing we want to make sure is that we have zeros, the number zeros, underneath the main diagonal. And so now you see that that has been accomplished right about here. All of the numbers that are under the main diagonal have to be zeros beneath the main diagonal. And once the matrix looks like this, it is considered to be in row echelon form. Row echelon form. Reduced row echelon form would also have zeros above the main diagonal, and that takes a lot more effort, and we're not going to do that. So the row operations that are okay to do, first one is you can interchange rows. You can swap them out, all right? Whatever's convenient. Interchanging rows is the same thing as interchanging equations. Top equation, bottom equation, doesn't matter that the first one was on top, or it could have been on the bottom. So you can flip them around. Each row corresponds to an equation. Okay. The second thing that's okay to do when we talk about row operations is you can multiply an entire row by a number, a constant, as long as that number is not 0. And we saw that quite a bit in the last section when we were solving our systems using elimination. We would multiply through by a constant, and that's okay to do as long as you don't use a 0. Positive constants and negative constants are all okay, not zeros. The third row operation that is okay to do is to add or subtract rows. And we saw this again in the last section when we added like terms together from one line to the next line. That's the same thing as adding two rows together in a matrix context. When we refer to the dimensions of a matrix, the dimensions of a matrix are how many rows you have by how many columns you have. And once again, the rows go across horizontally, the columns go down vertically. Okay, so you count how many rows go across by how many columns go down, and that is known as the dimension of your matrix. All right, so first thing I'm going to do is look at example number 6. All right, we have a system of two equations with two variables, and step number 1 is to pull off all of the numbers. Okay, so before you pull off the numbers, though, please be sure that your terms are in the appropriate orders. You've got the x term, and then the y term, the equal sign, and then the constant. They have to be in that particular order for this to work. Now you pull off the constants, you eliminate all of the other stuff that got into the way, and you write that as a matrix. We call this the augmented matrix. The augmented matrix is right here. And notice that that's what was done. We just pulled off the numbers. The dimension of this matrix, how many rows do you have? Count across. We have 2 rows going across, and then so that's a 2. And then the columns is how many columns you have going down, and that's 3. Okay? So we have 2 rows by 3 columns. So the dimension is 2 by 3. We're going to crank these row operations out by hand. There is a snazzy way to do these on your calculator. I will probably make a separate video to show you how to work this on your calculator, but for now, we're going to suffer through together and do the row operations by hand, so bear with me. All right, here's your augmented matrix, which is a matrix that contains all of the constants without all of the plus, minus, x, y equals getting in our way. Just the numbers. Matrices have these square brackets on either side. That's the notation in math to represent a matrix. All right, so here's a piece of advice. You know how I said that your goal is to have 1s on the main diagonal? Make that happen last. Don't do that right now, because eventually that's going to get undone and then you have to do it again. So the first thing I want to do is obtain my zeros. Okay, the first 0 location I want, you know what, I'm going to do this. This is my generalized matrix once again. 1, 1, 1, dot, dot, dot. 0, 0, 0, dot, dot, dot. Okay, so this is the order of things that I want to happen. The first thing I want to have happen is a 0 in that position. The next thing is a 0 in this position. If I do have another column here, I need a 0 in that position. Once you've got your zeros in place below your main diagonal, then you go back and you turn your main diagonal into 1s. That gives you an idea of your algorithm to sort of follow. Okay, so I'm going to make that first 0 happen, which is the 0 in the this position right here. Okay, I want that number to be turned into a 0. So how am I going to do that? Well, if I multiply the top row by a -4 and the bottom row by a 3, I'm going to have -12 on top of a 12. And then when I add those 2 rows, I get my 0. So let's continue with multiplying the top row by -4. All the way across, okay? Bottom row by a 3, all the way across. Make sure you don't make any mistakes, because it can happen. Next, you want to add those 2 rows together. And where are you going to put your result? Well, you're going to replace that second row with what you're going to get when you find the sum. Okay, so what I'm talking about here is you leave that first row alone. Just repeat that top row. And the bottom row gets replaced with the sum of the 2 rows. Okay, so -12 plus 12 gives you 0. That's where the 0 goes, because that's where we wanted it to be. -16 plus -6 equals -22. That goes right there. And then -28 plus 15 equals -13. So you've accomplished your first step. You wanted a 0 in that position, and you've gotten that 0.